Hello, my name is Terrell McCray, and I am a graduate student at Nova Southeastern University in the doctoral program in instructional technology and distance education. Today we're going to talk about a large-scale distance education project called MIT iLabs. Professor Del Alamo is the founder and principal investigator of the iLab project at MIT and continues to investigate the technology and pedagogy of online laboratories for science and engineering education on a global scale. iLabs are real experimental facilities that can be accessed through the internet from a web browser. Since 1998, under Professor Del Alamo's leadership, this project has developed several laboratory setups for electrical engineering education that have been used by thousands of students from around the world to carry out a variety of microelectronics device and circuit characterization assignments. The iLab project has also created the MIT iLab architecture, an open source toolkit of reusable modules and a set of standardized protocols to facilitate the rapid deployment and effective management of iLabs in remote and near locations. The iLab Africa project, launched in 2004, is Professor Del Alamo's flagship international initiative. iLab Africa is a Carnegie-sponsored group of sub-Saharan universities that are using iLabs in their curriculum and developing their own. Using a new scalable software framework called the iLab Shared Architecture, Professor Del Alamo led the development and deployment of online laboratories optimized for operation in developing countries. To date, this effort has enabled 1,000 African students to use MIT's lab in engineering and physics classes and has resulted in the development of many local laboratories in a variety of disciplines. iLab Australia is a growing consortium of Australian universities led by the University of Queensland that have already put 2 iLabs online and are currently developing nearly a dozen others.
We'd had problems with students doing pracs way before the material or way after because we only had N of the pieces of equipment. And we were looking for a better way. So the last job I'd done was built 2 labs with 50 bench positions in at a cost of $400,000. And we knew we were never going to get this money ever again. So we needed a way of better sharing the equipment we had. And we saw remote labs as a way around that, that if we could give students access out of hours, over weekends, they could run it from their homes at times of their convenience. It's not applications you download into your computer. The objective is run it in the browser. So it should run anywhere, anytime.
Northwestern University and MIT developed the iLab Network project to bring iLabs to K through 12, starting with high schools. The iLab network utilizes the internet to bridge the traditional gap between the research university and secondary school communities while recognizing the difference in educational context and goals. It offers a scalable solution to improving secondary STEM education by growing the use of labs to increase inquiry-based learning. The iLab connects lab devices such as microscopes and signal analyzers to the web. This allows teachers and students to access equipment remotely.
Geiger counter located at the University of Queensland in Australia. The lab starts with an interactive flash simulation that allows the students to see how the device behaves by moving it up and down and visualizing how the radioactive particles hit the Geiger counter. They can also get information and additional readings over here. For example, they could ask how's radioactivity measured, and they can get a reading on Geiger counters and how those measure radiation. Moving on, the student lab journal prompts the students for various questions and feedback. So here they need to write their research question. How does the intensity of radiation change as a function of distance? Next, I click design phase, and we're going to save the information to the server. Now the student needs to design their experiment. So I'll pick a short distance, say 30 millimeters to measure radiation at, and a distance that's further away, say 60 millimeters. And I'll measure for maybe 3 seconds each time. I'm not really sure if I'm a student, and repeat it 2 times. Then the lab journal asked me why did I want to choose these distances, and so I'll say, well, I wanted to try some close by and far away, and 3 seconds seemed like a good time to start with. I'm not really sure. So next I click investigate. My lab is then sent over to the device in Australia. I'm the number 1 in the queue. I've got about a minute left, and now I can switch over to a live webcam view of the device. Here's the Geiger counter on your left. There's a turntable that's going to spin the radioactive materials underneath. You can see the Geiger counter tube now moving up to my 30 millimeter distance that I typed in, taking the measurements, and then it's going to store all that data on our server for the students to then analyze later. Now you can see it's moving up to the 60 millimeter distance that I typed in. Again, it's going to collect the data. In the meantime, I could log off if I don't want to wait for it, or I can come back here and finish the prompt on my journal here. What is my prediction about what will happen? What do you think you'll see? And I'm going to type in, well, I think the intensity will go down the further away the Geiger counter is. In the meantime, the data is being sent back to the server, and if the student wanted to log back in, they would come back immediately to this screen here and pick up where they left off, so there's no need to wait. Once the data comes back, I'll be able to analyze it either by exporting it to Google Docs or Excel. So I could click here to export it, or alternatively I can use the built-in graphing tool that we have. So looking at my results, I can see that they do go down, but also they're a little bit different. So I'll write my initial observations are that the counts went down by about half, but each trial is different, so I'm not sure which number is right. So next I'll go ahead and fire up my analysis tool, do some graphs, insert those graphs in my lab journal, and then at the final question I'll explain that I think the relationship looks like a linear relationship with a negative slope, and I'll say, well, I probably want to run the lab again to see if the values I get keep changing. Finally, at the end of the lab, I can download a PDF, and then I can turn that into the teacher to complete my assignment.
Now you see the impact that MIT iLabs is having on distance education. Goodbye.